Okay, let's solve a differential equation. The example is find the solution or solve the differential equation x times y prime plus y equals to x e to the power x. So first we have to find the type of this equation. What you need to be able to check is that is it separable or linear. When you look at this equation, you have y prime times a function of x plus a y times a function of x equals to function of x. This means that the equation is first order linear differential equation. Well, then to solve it, we know what to do. First step is write it in the standard form. Remember, standard form is y prime should have no coefficient plus something in x times y equals to another function in x. Here I have an x multiplied to y prime. So if we divide the whole equation by x or multiply the whole equation by 1 over x, we will have 1 over x times x y prime plus 1 over x times y equals to 1 over x x e to the power x. Okay, so these two cancel, then what we find is y prime equals, plus 1 over xy equals to e to the power x. And that right away gives you the standard form, and in particular you can see that px is 1 over x and qx is just e to the power x. Very nice. So we found what is px and qx. Step 2, form the integrating factor. Form the integrating factor. Well, what was the integrating factor? You remember x is e to the power integral of px, that we call it the integrating factor. Here px is 1 over x, so integral of 1 over x dx. What is the antiderivative of 1 over x? Well, 1 over x is the derivative of ln x, so we have e to the power ln x. When you're trying to find integrating factor, you can drop that plus c part. And then an important property is here, e to the power ln of something is that something. So let me just maybe write it here. E to the power ln of anything is equal to that anything. Here, e to the power ln x is equal to x. So integrating factor here is equal to x. Very nice. When you have that, step 3 is use the formula and find the solution. Well, what was the formula? That this general solution is equal to 1 over ux times integral of qx times ux dx, and then don't forget that plus c in that antiderivative. Okay, so in this case it means that I have 1 over, remember, integrating factor is x, so 1 over x integral of, what is qx? Qx is e to the power x, so e to the power x times x dx. And then, well, don't forget to do this piece. When you write this, this is just you express the solution in terms of integral. We have to do integration, so we have to complete the integration. So here I need to compute this guy. And remember that x e to the power x, we can do it integration by parts. Set u to be e to the power x, and dv is going to be, sorry, u is x, and dv is e to the power x dx. Then from there, du is going to be just dx, 1 dx basically. From here, v is going to be integral of e to the power x dx, which is just e to the power x. And integration by parts says that it is x e to the power x minus 1 e to the power x dx, and that gives us x e to the power x minus just e to the power x. Okay, when you find this, just put it back. So this is 1 over x times x e to the power x minus e to the power x plus c. Well, you can simplify a little bit, multiply this inside, and what you get is e to the power x minus e to the power x over x plus c over x. And that's the general solution. So let me just summary write it. Y equals to e to the power x minus e to the power x over x plus c over x is the general solution for the differential equation.